In this video, I want to share the mathematical concept of factorizing. So I'll briefly give an overview of the concept and then go through some mathematical problems. So let's jump straight into the video. I'll focus on the topic of factorizing, the subtopic under the equations, formulas and identities topic. So what is factorizing? So if I do a Google search and do a brief overview of the concept or the conceptual overview of factorizing, if I just use two words, factorizing mathematics, in Google, what does it say? It says in mathematics, factorization or factoring consists of writing a number or another mathematical object as a product of several factors. This is the important part. Usually smaller or simpler objects of the same kind. So if I look at the Cider explanation, this is an AI tool. So factoring in mathematics is the process of decomposing an expression into a product of simpler expressions. So decomposing an expression into a product of simpler expressions. So you have one expression and you can decompose it into a product of multiple expression products, or the product of multiple expressions, simpler expressions. Okay, so if I do a demo or a mathematical problem overview, so I'll focus on the medium category of this question. There are three categories: easy, medium, hard. So I'll focus on the first problem just to give one demo. There is one expression, mathematical expression, x squared plus 3x minus 10. Factorize that. So if I use the notepad and let's say I make a page which is factorizing. Okay, so I want to simplify or factorize the expression x squared plus 3x minus 10. So the expression is x squared plus 5x minus 10. Okay, so I want to factorize it. So how can I factorize it into a product of two expressions or multiple expressions? So how can I do that? I can do that by using the middle term concept, for example, where I can make this term in this whole expression into a addition or subtraction. For example, the x squared plus 3x minus 10. So 10 multiplied by 1 is 1 into x squared. So 10 multiplied by 1 is 10. So how can I write the middle term into something that can be written as a addition or subtraction that results in thrice x? For example, x squared, 5 multiplied by 2 is 10. So I can write thrice x as what? Because 5 multiplied by 2 is 10, which is the result I want, I can write thrice x as what? 5x minus twice x minus 10. Okay, so this can also be written as what? So now I can use these two separate terms, these two separate expressions as two terms, okay, or two expressions. Okay, so if I take x common here, so x multiplied by x plus 5, okay, minus 2 multiplied by x plus 5, because as you can see, if I multiply minus 2 with x plus 5, minus 2x minus 10, minus 2x minus 10, and the first part is x squared plus 5x, which is x multiplied by x plus 5. So what do I get? X plus 5, because x plus 5 is same, so I can write x plus 5 into x minus 2. So as you can see, I have written this expression as what? As a product of two expressions, x plus 5 and x minus 2. So if I multiply x plus or do the product of x plus 5 and x minus 2, I get this expression, x squared plus thrice x minus 10. So this is how you can factorize one expression, this expression or a single mathematical expression, into a product of multiple expressions. Now I'll focus on the third question, which has two parts, 3a and 3b. So you have to factorize this expression, x squared minus 12x plus 27, and then you have to solve the equation x squared plus minus 12x plus 27 equals 0. So you have to first factorize this expression and then solve this the equation of that expression. Okay, so if I just use the first factorize the expression, so x squared minus 12x plus 27, you have to first factorize the expression. Okay, so how can you factorize the expression? Using middle term of the using the or deconstructing the middle term. So how can I deconstruct the middle term? 27 and 1 multiplication is what? 1 multiplied by 27 is 27. So how can I write 27 in a way that results in 12? So 9, if I use 9 and 3, then we can possibly get 12. So how can I deconstruct the middle term? X square minus, I can write 12x as what? Minus 9x minus thrice x. So because 9 multiplied by 3 is 27. So I can deconstruct it in this way, the middle term in this way. So x square minus 9x minus thrice x plus 27 is x square minus 12x plus 27. So now I can use these two terms as products. So if I can write x square minus 9x as x into x minus 9 minus thrice into minus 3 into x minus 9. So x square minus 9x, x square minus 9x minus 3x minus 3x minus is plus 3 multiplied by 9 is 27. So I get what? X minus 9 is same here. So we can write x minus 9 multiplied by x minus 3. So this is the factorized expression that are two expressions product is written, or the product of two expressions is written. So now you have to show what? You have to show that this equation is 0. So you have already solved or factorized the expression, which is what? The factorized expression is x minus 9 multiplied by x minus 3. So the equation is this, is 0. So how can you solve x? The product of two expressions, x minus 9 multiplied by x minus 3 is 0. So we can write, because these two product multiplication is 0, at least one of them must be 0. So if I write x minus 9 as 0, we get x is 9, and if x minus 3, at least one of them is definitely 0. That's why the product is 0. So x minus 3 is 0. If x minus 3 is 0, what do we get? The value of x, the value of x is 3. So the value of x can be either 9 or 3. This is the solution of the equation, this equation. So this is how you can first factorize this expression into a multiple of two expressions or product of two expressions, and then you solve the equation. I'll now focus on problem number 10. So this is an interesting problem. So there are two parts to it, 10a and 10b. So first we have to factorize this expression 6m minus 9. So if I use my pen tool in the notepad, this expression 6m minus 9, you have to factorize this or make it a multiple of two or the product of two expressions, not multiple but product of two expressions. So how can we do that? So at first glance it seems like I cannot make it a product of two expressions, but you can actually do it if you use the formula of a square minus b square. So we know the algebraic formula a square minus b square is a plus b multiplied by a minus b. So if we apply this formula like this, so what can we do? We can write something like 6m can be written as root 6m square minus 9. We already know that 9 is 3 square. So we can write the formula as a square minus b square. So what will be the result? Root 6m plus 3 multiplied by root 6m minus 3. Okay, root 6m minus 3. So you can write the formula as a plus b multiplied by a minus b. Be written as root 6m. So if I use the pen tool, so it can be written as this root 6m plus 3 root 6m minus 3, as this is the simplified product of two expressions of this expression. So we can write this expression as a product of two expressions using this formula. Now in the second part, in the 10b, it says that you have to fully factorize this expression 2x square y plus 4xy square. So 2x square, if you write the expression 2x square y plus 4xy square. So it's 4xy square. Okay, so we can take 2xy as common. So if we take 2xy, we get what? X plus twice y. So we have written the expression 2x square y plus 4xy square as a product of two expression 2xy into x plus twice y. Can it be more simplified? I can't see right now, so I'll keep it as it is. So you get the idea how you can make or factorize or make an expression a product of multiple expressions using formulas, algebraic formulas, and also taking commons like this in these two examples. Now I'll focus on two parts of 11. There are 4 parts of 11 in total. I'll focus on 11a and 11b. So if I first focus on 11a, you have to fully simplify this expression. So if I write this expression, let's say n to the power 7 multiplied by n cube divided by n to the power 6 multiplied by n cube divided by n to the power 6. So how can we simplify this? We can simplify because the enumerator or the numerator and the denominator powers can be subtracted. So I can write n to the power 7 minus 6 multiplied by n cube. So we get n multiplied by n cube, which is, there is power 1, so I'll add the two powers because they are products. So n to the power 4 is the simplified version of the main expression, which is this n to the power 7 minus n cube divided by n to the power 6. So now if I focus on 11b, you have to expand and simplify this expression, x multiplied by x minus 2 plus twice x multiplied by x plus 3. So x multiplied by x minus 2 plus twice x multiplied by x plus 3, twice x multiplied by x plus 3. So you have to expand and simplify this expression. So I have to expand and simplify. So first, if I just multiply the whole thing, so x multiplied by x minus 2 is x square minus twice x plus twice x into x plus 3 is twice x square plus 6x. So what do we get in total? X square minus twice x plus 6x, so it's plus 4x, and x square plus twice x square is thrice x square, so we get thrice x square plus 4x. Okay, so you have to expand and simplify. So I've expanded it, now I have to simplify. So what can we do to simplify this expression? We can take common of x. So what do we get? Thrice x multiplied by thrice x plus 4. So this is the product of two expressions, x and thrice x plus 4. So we have factorized this expression into a product of two expressions, x multiplied by thrice x plus 4. This is how you can first expand the expression and then factorize and simplify the expression. Okay, I hope by now you already have a firm grasp on the concept of factorizing in mathematics. So in the next video I'll focus on another interesting topic, so stay tuned for that.